Field lacrosse, sorry.
Lacrosse is that game where they tried to hit the other people in the neck with a stick, right?
Yeah.
Okay.
But like, you can also football hit it. You can like roll your shoulder and roll your
That's how that's how my friend explained it to me. He said the goal of lacrosse is to hit the other players in the neck with a stick. Like, that's pretty much the goal.
Well, actually, you hit them above the shoulders and they're kind of.
Well, of course you don't want to be seen when you're doing it. It's like any other sport, you know.
Yeah.
Or you need to, or the art of pretending you got hit above the neck when you actually haven't been, right? No, none of that. No, there's no flopping in lacrosse. Okay. All right. Well, good. I'll begin with a word of prayer. I think we're all here. Heavenly Father, we thank you for this day. I thank you again for this class, and I just pray that you just guide our steps, help us to glorify you what we do, and just to learn a little bit more about your creation together, Lord. In your name I pray, Lord Jesus. Amen. Okay, so we have been working on. So one of the things I keep forgetting to mention is, like, for just reasons I don't understand, if you've got the printed out like loose leaf version of the book, it has weirdly like renumbered the review sections. So what I have is R7. You might have as R5. Yes, thank you. So like the titles are relevant. It says like rational expressions. That's the one I'm talking about. So today we're going to solve some equations involving rational expressions. Let me get started on those. So example 1. So let's try our hand at 2x plus 5 over 2 minus 3x over x minus 2 equal to x. See if we can solve this. What approach do you guys think we should take here? What's our general rule of thumb with fractions? We want to. Well, yeah, but do we like working with fractions? We want to get rid of them. How can you get rid of the fractions? Add? Multiply? I guess it's got to be one of those things. Maybe subtract. No, no. We should multiply. So I would say multiply by the least common multiple, and so here I'm going to multiply by 2 times x minus 2 just to make things nicer. And so I've got 2x plus 5 here over 2 minus 2 times x minus 2 times 3x over x minus 2 is equal to x times x minus, I've lost my 2, haven't I? So 2 times x minus 2. So I'm just multiplying the whole thing by 2 times x minus 2. The reason I'm doing that is because what happens? These cancel, right? Or over here, right? And then what do we have? We have 2x squared minus 4x plus 5x minus 10. And then over here, I believe we have a 2 times 3 minus 6x, right? And that's equal to 2x squared. 2 times 2 is 4, so minus 4x. So I just distributed everything out. Is there anything that we can do from here? What should we do? Combine like terms? I think that's a good idea. I mean, I would subtract 2x squared from both sides because, I don't know, it's nice to not have that there, right? Oh, look at that. It's gone as well. So what are we left with? 5x minus 6x is, bless you, minus x minus 10 equals to 0. Also known as x equals to minus 10. All right, now with any of these problems, you got to ask yourself a question: does it actually make sense in the original equation? All right, and so I think it's fairly obvious that this one does, right? What would the one answer that we'd have to throw out if we got an answer as an answer here? What would it have been?
2.
Yeah, if we got 2, then that would have been bad. Let's go on. Example 2. Unless there's a question, you guys can chime in if you got questions. Nobody? Okay. Hup. It's fine. I know you guys just want me to, you figure no questions, class ends earlier. I got it. 7 over x squared, I understand the play. 7 over x squared plus 19 over x is equal to 6. Work this in the last section. I like this problem. It's kind of pretty. So what do I do?
Multiply 19 over x by x. Then you have x squared.
Well, yeah, if I multiply this equation by x, it fixes the 19, but I still got a 7 over x then, right? So what we should do is we should multiply the whole equation by x squared, right? So what's that give me? That gives me 7. And then x squared over x is what? X. So 19 plus 19x equals to 6x squared. And then it's a quadratic equation, right? So what do? Move everything to one side, okay? I like to keep the, coefficient of the x squared positive just to keep things pretty. Now, is this right or wrong? Obviously what I'm doing is wrong. Excuse me, 19 minus 19x minus 7 equals to 0. So how should we solve this?
Add 7?
Do what?
Should we add 7 to make 7 to the other side?
Well, that won't help. I mean, this is, I mean, we always, we try to factor, right? It's a quadratic equation, so we want to. If I put 7 to the other side, that doesn't help me though, because I don't know anything special about like numbers that multiply to 7. Complete the square. So we could complete the square or we could factor. If you can factor, it's faster. Can you factor? I see no's. I mean, we're going to have to put a 7 here and a 1 here if there's anything nice. And 6 you can either break up as 1 times 6 or 2 times 3, right? I want a 19. I better pair the 7 with a 3. And if I pair the 1 with a 2, I think we got something, right? Because then, what should I put? Plus, minus, minus, plus? Minus, plus, right? And, yeah. Now what if you don't see that? Then we can complete the square. We could use that method, right? So we have 2x minus 7 equals to 0, or 3x plus 1 equals to 0. You're like, well, why did you think you could factor that? Well, the reason I thought I could factor that is I just pulled this problem from a book. And this is in the remedial section. I'm sorry, the review section. And, my bad. And so being that it's in the review section, that means it should have easy factoring, generally speaking. And this, I mean, is it easy? Maybe easy is the wrong word, but not hideous. All right. Any questions? So what's the method? The method is to get rid of fractions and solve for x, right? What if we have like x over x plus 2 equals to, like 3x over x minus 1? Can we solve this? Cross multiply, yes. Do you guys know cross multiply? So we put x times x minus 1 is equal to 3x times x plus 2. This is cross multiplying. This is logically equivalent to just multiplying both sides by the product of the denominators, right? But we have a reduction of the x plus 2 on the one side and the x minus 1 on the other. Anyway, so multiply it out, what we got? We got x squared minus x is 3x squared plus 6x. And So let's put everything on one side. We've got 3x squared plus 5x. Is that it? Oh, 2x squared. Oh man, I wanted this problem to be hard. Rats. This is like super easy and stuff.
Don't you want it to be easy?
No, I wanted this one to be a pain. This is like, oh, 7x? Oh yeah, thank you. All right. Okay, so then I can factor out 2x times x plus what? I heard a 7. If I put a 7 here, does that, if I multiply it out, I get 14x, right? I have to put a 7 over 2 if I do that. See, the ultimate judge is when I multiply it out, do I get back where I started, right? Factoring is unmultiplying, so. What are the solutions? X equals to 0 and x equals to minus 7/2. Are either of those objectionable in view of the original equation? No, our trouble would be, we would have trouble if we had -2 or 1. We have neither of those, right? So that's good. Let's. What's that?
If we did get -2 or 1, we just don't use the answer.
Oh, then there's no solution, if that's all that there is. Sometimes you get 2 answers. One of them is legit and one of them's not. That can happen. Let me see if I can find one where that happens. I mean, I worked one where that happened earlier today. If I could remember which one it was, I'd give it to you right now. But well, let's try this one. Example 4. Well, we'll come back to that. What if we had like 3 over x plus 2 is equal to, oh, I don't know, like 2x over x minus 1. Let's see if we can solve that one. So yeah, it's kind of the same example, but I want it to be ugly. So here we go. This is 3 times x minus 1 is 2x times x plus 2. This is not the example you were asking for, by the way, okay? I'll circle back to it, but this gives me what? This gives me 3x minus 3 is 2x squared plus 4, which gives me 2x squared minus 3x. What did I do? 4x? Yeah. Oh, okay. Thank you. My bad. So what's that do? 2x squared. Oh, 2x squared plus x, isn't it? 2x squared plus x. Ooh, that is ugly. 2x squared plus x plus 3. Let me step away from it, make sure I didn't make a stupid mistake. 4x, 3x minus 3, yeah, 2x squared. I subtract, no, it's subtract on the other side. Yeah, I think we're good. Now, so here, I will complete the square. So I'll divide by 2. Since we're dealing with an equation, I might as well do that, right? And then I do what? I do x plus 1/4, square that thing. And then I subtract a 16th and add 3/2. And then isolate the square. Let's see here. What's 1/16? Whoa, really? Interesting. Is that right? Interesting.
You wanted an average? Yeah, you wanted an average.
Yeah, I wasn't expecting this to happen. So what is that? I mean, it's negative, right? What's that? So what you guys got for me? minus 8/6.
It's minus 9/6. Oh, that. Yeah.
So that means that x is equal to minus 1/4 plus or minus, that feels really wrong. Oh, good grief. Look at that. Sad. Sad, sad, sad. Yeah, 1/16. Duh. My bad. That's what? 3 times 8 is 24. 1 minus 24 is negative 23 over 4, or 16 rather. So we get 1/4 plus or minus I times the square root of 23 over 4, right? And so I guess if we were looking for complex solutions, then there you go, that's the answer, but we're not. Right? So in as much as we're looking for real solutions, the answer to this one is no solution. So that's funny to me. I'm surprised that doesn't have a solution. Huh. It's really bothering me that it doesn't have a solution. Oh man, I'm gonna forget what it is. Ah!
It's okay. It's 3 over x plus 2 equals 2x over x minus 1.
Oh, we haven't top hatted yet, have we? Your life is incomplete without top hat, right? Top hat is this dumb thing we do in all our classes for attendance. It's really, really annoying.
There's no point in I think it's best that we end class here. I'm just like,
I'm not gonna end class here. That would be like,
can
that would
we
be so
all swap
sad.
another lecture?
No.
I'm so
I have many more things to cover today. The top hat is 5013, 5013. All right. So let's just investigate what the meaning of the last example is for just a second. Just humor my curiosity here for a moment. 5013. So, do you guys know? I think have I showed you guys Desmos before? I don't think I have. So, what were the equations that we were just solving? Y equals what? I mean, what was the equation?
3 over x plus 2.
3 over x plus 2.
What was the code for top hat again?
5013. That was the 3 over x plus 2 was the left-hand side? What was the right-hand side?
There was 2x.
Was it x over, or 2x? Divided by what? X minus 1.
Change the sum equal to
Aha, that makes sense. So this is the graph of the right-hand side, that's the graph of the left-hand side. Never the two shall meet. That's why there's no solution. There's no intersection. It makes sense. So of course, you're allowed to use Desmos on the test, so this is super helpful to you, right? No, it's not true. Not true at all. Anyway, we will come back to graphing these. I had, you know, a feeling about that problem that I wanted to, come on, let me, system's turning on. Really? Ha-ha. Ha! Class goes on. Take that. You sing that song, I will go 15 minutes over. All right, one final example of solving equations. I'm going to hopefully find your example. Golly. Maybe it's this one. 4x plus 3 over 4 minus 2x over x plus 1 equals to x. Maybe this is going to be the one. All right, so can we solve this? Well, I think what we should do is we should multiply the whole equation by what? 4 times x plus 1, right? All right, so we've got 4s. 4s are canceling. X plus 1s cancel over here. That gives us x plus 1 times 4x plus 3, which I should multiply out. And over here, we got ourselves a minus 8x. On the other hand, the right-hand side, we've got a 4x squared and plus a 4x, I believe. FOIL this out. We got ourselves 4x squared plus 4 plus, that's plus 7x, plus 3 minus 8x equals to 4x squared plus 4. I'll get out of the way here in a second. It occurs to me I never, oh, did you move the camera for me? Well, thank you. I am my own worst cameraman. If you're really curious what else goes on in here, it's on YouTube if you want to watch more. And the higher level classes if you want to see like math major. Yeah, still there. So these cancel. And we get what? We get minus x plus 3 minus 4 equals to 0. Also known as minus x minus 1 equals to 0. Also known as x equals to minus 1. Yes! It's very exciting. This is what we wanted. You're like, why do you want this? So you were asking me, what happens if it's one of the ones that's not allowed, right? So this is what we call an extraneous solution. It's an apparent solution that's not actually a solution, right? So it's extraneous. So you just put an x through it and you say extraneous. And then you say no solution for this one. Now sometimes you have two solutions. One of them's extraneous. You cross one out, so you still have a solution. But this time there's no solution. I always tell students at this point in the semester that if I was to be a rapper, I would be extraneous G. And my tagline would be, I'm not even in the solution set. So I've been waiting all semester to tell you this. It finally happened, and it happened on CFA this semester, which is magical. As I planned. Yes, extraneous G. I say this every semester. You might guess I have the soul of a rapper. See, it's true. I have no flow, though. None at all. All right, so I think that's it for solving equations, which means that class is not over, because we still have to solve inequalities today. Aww.
Yay.
So, let us begin with a truly hideous example. You guys ready?
Can we just do the worst example?
Example 6. Man, you guys are getting lazier. Example 6. So here we go. You ready? X plus 10 squared times x plus 6 cubed times x minus 4 to the 4th power divided by x cubed times x minus, oh, I don't know, 3 times, I feel like a 7. X minus 7. Do you guys want squared or cubed? I'll let you choose.
Squared.
All right. Squared it is. Now, do you want less than or equal to or greater than or equal to? Student's choice. All right, greater than or equal to 0 it is. So I made this problem very easy in the sense that it is already, we're going to try to find the solution and write this solution in your favorite interval notation. I know you guys love interval notation so much that you didn't use it on the test because you were afraid you were going to use it incorrectly and offend the interval notation. So you're trying to like show due deference to interval notation by not using it. For the fear that you would used it incorrectly, you venerate the interval notation that much. It's very something. But you should learn interval notation as to receive more points from me, yes? I have too many of your points right now. I would like for you to keep more of them in the future. So anyway, this has how many interesting numbers? Well, there's 6 interesting numbers here, right? So we need to expand our idea of critical number to either be places where the numerator is 0 or where the denominator is 0, right? So these are all, I would call them critical numbers here. They're places where the expression could change sign, all right? So critical numbers. So if you're a math major, this is slightly offensive as there's a more technical meaning for critical numbers that none of these students know about. So you'll keep it secret, right? Okay, no? You don't remember? Okay. All right, I'll stop. The derivative was either 0 or undefined. That's usually what we mean by critical number, but anyway. So here, the critical numbers are what? And we should try to get them in order. What's the smallest one in the sense of number line, the most leftward number? This could be 0 when x equals to what? Minus 10, right? So minus 10 is my first critical number. What's next? Looks like I think minus 6 is the next one. Right? This is just like the factor theorem. Remember, guys, like f of c equals to 0 means x minus c is a factor. It's that we flip the sign with the number versus the factor. What's next? Zero's, yeah, I think 0's next from the x cubed. And then what? I heard a 3. Okay, and then a 4, and then a 7. So those are your critical numbers. So that, first of all, identify your critical numbers. Make sure that there are no repeated factors. Like if there's factors that are repeated, you got to group them together. Otherwise, you'll miss something. All right? So there it is. And then I draw a number line. All right? And I put these down. They don't have to be exactly, to scale or anything. It's just an organizing chart, right? It's not a doesn't have to be to scale, right? So just enough to keep track of things. Now what I do, excuse me, is I put in a big number to figure out what happens to start with somewhere, right? So usually what's a big number for this? Like maybe
12.
I take your 12 and make it 10, because why not? Well, 10 is easier, because then I can think, find 12 if you must. 12 plus 10, 22. 12 plus 6, 18. 12 minus 4, 8. 12 cubed, whatever. 12 minus 3, 9. 12 minus 7, 5. So we have positive, 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 all positive numbers, right? I don't actually care what the number is. I just want to see, is it positive or negative? And it's clearly positive, which starts us out with pluses over here, right? And then I'm going to use the sign flip theorem that allows me to just propagate the signs over without plugging in any more points, right? I'll use this hideous Carolina blue to complete the thing. So it's 7. It's coming from x minus 7 squared, right? The multiplicity of this factor is 2, which means we bounce. We stay positive here.
What if we don't want to be positive?
Well, I mean, you could get the problem wrong. I mean, I don't force you to have right answers. I mean, it's a free country. If you can't fail, you're not free, by the way. General point of order. So 4. Yeah, that's a multiplicity 4, which means we bounce again, so it stays positive. And 3 is coming from this. That's just one of them, right? So it's going to flip signs there. So we go negative. And then at 0, I've got a cube, so we flip signs there again. At minus 6, it's a cube, so we flip signs there again. At minus 10, we've got a square, so we stay negative. So we bounce, we maintain the signs as we go across even multiplicity factors, and we flip signs as we go across odd multiplicity factors. But it doesn't matter whether the factor's in the numerator or the denominator, the rule is still the same, okay? So now we're trying to solve greater than or equal to 0. What should I be looking for?
Things that are greater or equal to 0.
So I should be looking for what? This, and this, and this, right? And which, if I'm solving greater than or equal to 0, what should be in my solution set? Solution set should contain the numbers minus 10, minus 6, and 4, because those make this expression 0. If we have 0 in the numerator of a fraction, that makes the fraction 0. So that's it. All right, so let's do it. So this is kind of weird. This is like a really weird starting point, but I need minus 10 in the solution. So to do that, I write curly brackets minus 10. There we go. That puts minus 10 in the solution. It's weird, but that's part of the solution, because this point is part of the solution. Dunk. Then what comes next is minus 6. Well, minus 6 is on the edge of something. Minus 6 to where? To 0. Now, is 0 included or excluded? Why must it be excluded? See where it is? It's coming from this. If I plug in 0 into the expression, I get division by 0. That's not part of the solution set. So we put a parentheses here to indicate that. Then I take the union with 3. Now, is 3 part of the solution? It is not, because again, you got division by 0 at 3 from this factor right here. That takes us over to 4. Is 4 in the solution set? It is. And then I take the union with 4 to 7. Is it in the solution set? It is not. So we could write these two things simply as what? So if you wrote this as your answer, I would give you full credit, all right? If you write everything here except for the minus 10 as your answer, I'd probably still give you full credit. I don't usually take a point off the student's solution. If they have everything else right and they just forget the minus 10, I don't usually deduct anything because it's kind of weird. And anyway, so this here, you could write as 3 to 7, right? That would be logically equivalent here. Because it's the whole deal from 3 to 7 not included is making the expression positive. So anyway, so let me write the answer in like the nicest way possible for me. Minus 10, union with minus 6 included to 0 excluded, union with the set 3 to 7. There you go. That's your solution in interval notation. If you understand what we just did, you can solve the lion's share of these problems, provided your algebra is solid enough to get to this point for other problems. So what do I mean by that? Well, they don't always look like this, do they? And it can be relatively simple. It can be relatively simple, but it still involves a little bit of algebra here. Let me show you one. So, for example, if we had, I don't know, 10 over x plus 3 greater than 1. How would you solve that? Multiply by x plus 3. See, the danger in that would be that I don't know whether x plus 3 is positive or negative. So then I would descend into like case-wise analysis, which I'm trying to avoid. So let me do something less exciting, which is to put everything on one side and make this a greater than 0 problem. So that's what we do. And then we need to make a common denominator. So how do I change a minus 1 to an x plus 3 kind of fraction? I do what? Yeah, minus x plus 3 over x plus 3, right? That's how to rewrite 1 as a fraction with the same denominator. Now I can do the subtraction. I have 10 minus parentheses x plus 3. Don't forget to distribute the minus, which is actually 7 minus x over x plus 3 greater than 0. Now we're back to the same kind of starting point as my previous example. We can do this, all right? So the graph, so I make my number line, right? What are the critical numbers for this one? -3 and 7. I believe that you're correct. And we're going to get sign flips both times. They're both odd factors. Like the multiplicity of both factors is 1. So let's see here. So just plug in something. Where's 0 in this story? It's in the middle, right? Yeah, in between exactly what you said. So I plug 0 in here. I get what? 7 minus 0 over 0 plus 3, also known as 7/3. Positive or negative? It's positive. So I got positive sign here. Sign flip says I put minus over here. I put minus over there. So what's my solution? Now I'm solving it to be what? I'm solving it where it is greater than 0, right? So that means I do -3 to 7 from the number line right above. So the method to solve these is the same method we already did. We already talked about how to solve polynomial inequalities, right? Same exact idea. What's the new wrinkle is that we can have critical numbers from polynomials in the denominator, and those give us division by 0, which we have to avoid. Whereas the numerator, we're still going to include them if we're looking at like a greater than or equal to problem. Here we weren't, so we excluded both of the critical numbers, right? So I think that's it. So have a good weekend, you guys. Sorry I didn't end as early as